series now. 7.1 part 1 was on sequences. What we're going to do in this lesson is we're going to learn what series are, learn sigma notation, and use it with series. We're going to find terms of a recursively defined sequence, and we're going to look at a series and write the sigma notation from that series. So let's look to see what a series actually is. If you look at what we have on this screen, we have an infinite sequence that is just in generic terms. We have a sub 1, a sub 2, a sub 3, and so on, which goes on forever. The difference between a sequence and a series is that instead of putting commas between each term, we're going to put a plus sign and actually add each term. The sum of the terms in this one is an infinite series because it doesn't have a stopping point. A partial sum is where we actually do stop somewhere and only add up a certain number of terms. It's also known as a finite series or an nth partial sum. I usually refer to it as a finite series. What we denote it as, and what we use is S sub n, meaning that we're going to take the sum of the first n terms. So let's look at our example here we have down at the bottom. I have a sequence that is one of our alternating sequences, -2, 4, -6, 8, and so on. And in your homework and what we see here is we are going to find the sum of the first term. That's kind of silly, isn't it? But that's possible. So the sum of the first term just happens to be -2. I'm not adding anything onto it. I just put the -2 here. To find the sum of our first 4 terms, that's what the S sub 4 stands for, I'm actually just going to take my first 4 terms, -2 plus 4 plus -6 plus 8, add them together, and I get 4 in this case. S sub 5 means I'm going to take the sum of the first 5 terms. It looks just like S sub 4, but I add the next term in the sequence, which is -10, and I end up getting S sub 5 is equal to -6. But we don't always just use S sub 4, S sub 5 for partial sums. We also use sigma notation. This is one of those things that looks kind of scary, but it's not. The sigma is this big E-looking letter. That is the Greek letter sigma, and it is the capital sigma. It has certain parts that will always be the same anytime you use the sigma. The sigma is for summation. Summation means to add the terms together. Each part of the sigma notation is equally important. You need all these parts before you can use sigma notation. Our first part is this j squared here. It varies every time, but this just happens to be an example. And that is our formula. That is what we're going to use to find the terms of our sequence that we're going to add, the terms of our series. You notice this j and this j are the same letter. The j underneath the sigma is known as our index variable. Sometimes you'll see it called the index of summation also. That is where you're going to start putting, that is the part of the formula where you're going to start putting in numbers. This number here that says j equals 1 is our starting number. In this case, we're going to start putting in a 1, and then the next number we would put in would be 2. The next number we put in would be 3, and so on, to find the terms that we're going to add together until we get to the number at the top. Here, this is n. Let's say that number was actually a 4. That was the number we would end on. What we would do for this particular series then is do 1 squared plus 2 squared plus 3 squared plus 4 squared. Add those together, come up with a number at the end, and that would be our summation as j goes from 1 to 4 for j squared. So let's practice some. So here I have my index variable being k. My formula is k to the third. I'm going to start putting numbers in for k starting at 1 and go up by whole numbers or integers till I get to 5. I end up with something that looks just like this. 1 to the third plus 2 to the third, all the way up to 5 to the third, and then I stop, and that equals 225. I did the math for you. Our next example, we have an alternating sequence here. You can tell that because of that -1 to the k, where k is our index variable. But note the difference here. We're not starting at 1 this time, we're starting at 0. So I'll start at 0 and I stop when I get to 4. So all I'm going to do is everywhere I see a k, I'm going to put in a number. And you can see my first term is -1 to the 0 times 5 to the 0. Then I do plus -1 to the first times 5 to the first. And so on until I get to number 4. You notice it's not just the first 4 terms. I end up with 1, 2, 3, 4, 5 terms here because I started at 0 and went to 4. And once again, I did the math for you and I came up with 521. C is one that you're going to do on your own. Please note that you're starting at the number 8 and you're only going to 11. So you would have 8, 9, 10, 11 for your terms that you put in for I. Bring that to class with your answer, please. Next on our agenda is recursive sequences. What this means is you have a sequence. To add these together, it relies on the previous term. That's a little confusing till you see what I mean. So we're going to give you the first term or the first few terms of a sequence and a formula. And from there, you'll be able to find the remaining terms easily. Here's a very famous one that you've probably seen before many times. Bring your answer to class. Do you know the name of this famous sequence? And see what you can do with that answer. So let's see what a recursive sequence looks like in action. Okay, come on screen. It's working in slow motion today. Okay, we had this example where we find the first 5 terms of a sequence, and we're going to let n be greater than or equal to 1. Here is our formula. A to the n plus 1 is equal to 2 times a sub n minus, oops, I think I said that wrong. That's a sub n plus 1 is equal to 2a sub n minus 3, and a sub 1 is equal to 5. So we gave you one of the terms, and we gave you the formula. Whenever you see a sequence, or excuse me, a series that says n plus 1, or excuse me, a sequence, not a series, it's a sequence, n plus 1, you can assume safely that it's a recursive sequence. So let's go ahead and see how this works. I have a sub 1 is equal to 5. What I'm going to do here is find my second term, my a sub 2, because I already have a sub 1. A sub 2 is actually equal to a sub 1 plus 1. See, this is n right here. This one goes, those go together. So what I'm going to do now is put 2 times a sub 1 minus 3. I'm going to take my a sub 1 and it goes right here. And I have 2 times 5 minus 3 equals 7. I use my previous term. We're going to continue doing that for the first 5 terms. Here, I take this 7 and I put it in the formula for the third term. There's our first term, second term, third term is 2 plus 1. So what I'm doing is going to take my a sub 2 and put it right here for 7. Take my a sub 3 that I just found, put it in to find a sub 4. My next term, my a sub 4, I put it in to find a sub 5. And I'm done with my recursive sequence. So here's one that is used in a word problem. We have Tori is paid $8.30 per hour for working at Red Freight Limited. Each year he receives a 30-cent hourly raise. I don't think I'd want to work there. Anyway, give a sequence that lists Tori's hourly salary over a 10-year period. So what I did is simply used formula where we know a sub 1 is equal to 830. And each year he gets a 30-cent raise. So for the first year, it's a sub 30. Second year, we take this 830, we put it in for a sub n, and we add it together. So the second year, he's making $8.60. The third year, you take the $8.60 and add 30 to it. The fourth year, you add $8.90 and add 30 to it, and so on. Please finish this for class up to the a sub 10. And last but not least, we're going to write sigma notation for each sum. These are your steps. We have a sequence here of numbers 1, 2, 4, 8, 16, 32, 64. Before we can write sigma notation, we need to find the general term. I found the general term for this particular sequence to be 2 to the m minus 1. There are a total of 7 terms. So to write this in sigma notation, I wrote it as m is equal to 1 as it goes to 7 with this formula, to the m minus 1. We'll go over more in class on how to find this general term. Once you find that, the sigma notation should be easy. The general term for b, I found to be negative 1 to the k times 2k. That is an alternating sequence, so I know that it's going to be negative 1 to the k will always be in an alternating sequence. There's 1, 2, 3, 4, 5 terms. And I put it in sigma notation. The variables I just made up, okay? I just made up the variables. For this next one, I would like you to try to figure out what is happening to n, use n as your variable, and write it in sigma notation, please. So I can give you the hint. It's going to look something like this. So there's 1, 2, 3, 4. Oh, wait a minute. That's infinite. Pretend like it stops right here, okay, guys? So this stops right here. Ignore this part for right now. And that's it. See you in class.